Hello everyone, I hope all is well. As you can see, today's title is Coordinate Geometry 2 Circles. So of course we're focusing on circles, and I'll start off by showing you the equation, or how to work out the equation of a circle. So this point has coordinates x, y. The radius is lowercase r. If I draw a right angle triangle, then the height of a right angle triangle is y, and the base is x. So now, using Pythagoras' theorem, I'm going to write x squared plus y squared equals r squared. Now you might recognize that as the equation of a circle, or the general form to the equation of a circle. Now I'm going to show you something else which links to one of the identities we learnt about during the trigonometry topic. So I'll draw the right angle triangle again. I'll write y here, x here. But let's say we know that this angle is angle theta. Then we can say cos theta is adjacent over hypotenuse, and sine theta is opposite over hypotenuse. So let's just label this triangle. This is our hypotenuse, opposite is y, adjacent is x. So cos theta equals adjacent, which is x, over the hypotenuse, which is r. Sine theta equals y over r. So now if we make x the subject here, it's r cos theta, and here we have y equals r sine theta. So what I'm going to do now, using this orange color, is I'm going to cross this out and write r sine, alright, like this, r sine theta Here we have r cos theta. Now let's use Pythagoras' theorem again. So r cos theta squared plus r sine theta squared equals r squared. So we have r squared cos squared theta plus r squared sine squared theta equals r squared. And let's say r in this case is 1, r equals 1. Then we have 1 squared cos squared theta, so I'll just write cos squared theta, plus 1 squared sine squared theta equals 1. Now remember, this is a really important identity which we used a lot in when we were learning about trigonometry. So we've just proved that using this circle. Of course, the general form would be, you could write r squared cos squared theta plus sine squared theta equals r squared. And of course, if you then divide both sides of this equation by r squared, you'll end up with cos squared theta plus sine squared theta equals 1. So I wanted to show this to you guys, firstly because it is quite interesting to see the link between a trigonometry identity and coordinate geometry circles, equation of circles, but also because you may see a question whereby you have to use both of the topics I've just discussed, and so yeah, I felt that it's quite useful to show you guys this. So now, as you can see, we covered the first half of coordinate geometry in last week's lesson. We'll now continue and do the next half of it, the second half, which consists of these learning objectives you see on the screen. So hopefully by the end of today's lesson you will be able to do all of these. Just to show you again, if there's anything which doesn't make sense during today's lesson, or if you just want to do some further independent learning, you can use the resources under this heading when you go on to coordinate geometry 2 circles. So you have notes and examples, some walkthrough tasks, or just one walkthrough, and then you have some YouTube videos as well. So feel free to check those out. So here we have the general form, actually a specific circle. Of course the radius is 5, well that's clear from the graph, and so the equation would be x squared plus y squared equals 5 squared, and so this is the general form. Of course you should have written that down in your books by now. Here we have some questions for you guys to answer. So the questions are quite simple and you probably know how to do this from GCSE. So you don't necessarily have to write anything in your book. You could just answer these in your head. I'll go through them one by one so you can pause the video, answer it. As I said, you could do it in your head. You could write it in your book if you think you will benefit from that. So the first one here, it's very clear that the radius is 1. So we have x squared plus y squared equals 1. Try to do the second one. I'll try to work through this quite quickly as well, because I'm aware that some of you know how to do these types of questions. Here our radius is 3. So that's how a circle looks like. So we've done these two. The third one, of course, it's x squared plus y squared equals 16, because 4 squared is 16. R squared is 64, so R has to be 8. Here our radius is 10, so our equation is x squared plus y squared equals 100. And for the next circle, our radius is going to be square root of 36, so our radius is 6. So how could we show that these that our x and y are related? So this is just a repeat of the proof I did on the first slide, but I wanted to show it to you again because we're now going to use it to understand the equation of a circle when the center is not the origin. So here you can see the center is A take away B. I just want to remind you of the relationship between the radius and the x and y coordinates. So moments ago I said that we could use Pythagoras' theorem to write x squared plus y squared equals r squared. What about when the circle does not have its center at the origin and instead the center is AB? How do we work out the equation of the circle? So let's say this point here is x, y. So y here, x here. Now I'm going to include the A and B. So this is A. And so, as it says here, what would the sides of this right angle triangle be now? So the height would be y take away b, and the base will be x take away a. So now using Pythagoras' theorem, we have x take away a squared plus y take away b squared equals r squared. Please could you write down the general term in your books? I am aware that you guys learn about this at GCSE, but it's just really important to recap it now, as we will be doing some harder questions today, hopefully. Here we have some more quick fire questions. Now again, I am aware that some of you will find this easy, so feel free to work through it very quickly. I'm going to try to go through it quickly as well. The equation to the first circle is x squared plus y squared equals 25. The equation to the second circle, well, now we can see our a value is 1, our b value is 2, and our radius is 6. So this is our equation. And so essentially what you're doing is you're using this equation and the information you have here to identify the center and radius to each circle. So I'm going to go through the answers slowly. So if you have answered it, then you can mark your work. If you're finding it too easy, then hopefully we will have some questions later on which are a bit more of a challenge. So yeah, so far everything we have done is GCSE level. Here as well, I'd like you to pause the screen and think about which of these equations are circles and which ones do not represent the equation of a circle. So I will go through the answers now. X squared plus y squared equals 15 is the equation of a circle with a radius of root 15. X squared plus y squared equals negative 100 is not the equation of a circle, and that's because this term here, this r squared, has to be positive. Think about it. How can we have a square number which is not a positive number? It doesn't make sense. Here we'll have to rearrange, and so we'll have x squared take away y squared equals 144. This is not the equation of a circle because let's just look at the general form again. We have to have a positive sign in between the x squared and y squared terms. So using the same principle, this equation is not the equation of a circle. And moving on to the last one, if we plus y squared to both sides, we get x squared plus y squared equals 12. And this is the equation of a circle with radius root 12. Today's lesson, I will go through some of the resources on integral maths as I did last week. So we're going to start off with this explore circle equations link. Please feel free to go through these by yourself as well at a later point. So here we have a circle. If I adjust the a value, that moves our center of the circle to the left or to the right. And the same with b, although it affects the y coordinate of the center of our circle. The radius, of course, will make our circle smaller or larger. So it's becoming smaller here, and it's becoming larger here. And actually, just spotted this now, show triangle. That's really useful. it helps you understand the relationship between Pythagoras' theorem and the equations of circles. So I'd like you to have a go at, let me just check something. So explore. Yeah, have a go at this skill pack, I think it's called. Yeah, skill pack. Practice. Enter the coordinates of a center and the radius with equation. Okay, so this is a very simple question, which I'm sure you guys will be able to answer without any issues. Now let's go on to the expanded form. It's a bit more tricky, so I'm going to go through this now. The equation of a circle is x squared to equate 4x plus y squared to equate 6y plus 4 equals 0. Now we need to work out the center and radius of a circle from that. So we write it out, complete the square on the x terms and on the y terms. So then we end up with this after we complete the square. Then as you can see, we have three constant terms, -4, -9 and +4. So we need to collect them together and move them over to the right hand side. So then we get a 9 on the right hand side, and so now it's in the form which we want it to be in, right? So we know what our a and b values are, and we know that the radius will be the square root of 9, which is 3. So you have a go at some of these practice questions. If you click on the new button, it will generate a new question for you. Coming back to the lesson, activity 1 is to answer some problem solving questions, and as I did last week, as we did last week, I'd like you to pause the video, answer the question, then mark your work. There are 3 questions in total, and I will provide hints as well, and I'll explain that more in a sec. So here we have the first question. If you feel confident on answering this question now, then have a go at, well, just pause the video and answer the question. If you'd like a hint, then I'll provide a hint in a few seconds. So my hint for this question would be labeling the sides of this square. So I'll say A, and A. Hopefully using my hint you were able to identify that this coordinate is A. Now after you do that, well, you know that the equation of a circle is x squared plus y squared equals 36. So you'd have to substitute AA into this equation, which gives you 2a squared equals 36, a squared equals 18. And so the area of a circle is going to be a squared, right? Because, well, yeah, the area of a circle is a multiplied by a. So in this case, a squared is 18. So here is the second problem solving question. Pause the video if you would like to get started now. In terms of the hint I will provide for this question, well, we can see, I'm going to use the larger circle. So if this is x equals 4, then this will be 4 as well, right? Because it's a circle, the circle would touch the x-axis. If it touches the x-axis at 4, then it would touch the y-axis at 4 as well. So that is your hint. Please pause this video now and try to answer it independently. Okay, so if this is 4 and this is 4 as well, the center will be 4, 4. And so from that we know that the small circle has a diameter of 4 and a radius of 2, and the larger circle has a radius of 4, right? Actually, use a different color. Yeah, radius of 4. And as it says here, pi r squared for the smaller circle, for the larger circle, if we use pi r squared, we have 4 times pi, which is 16 pi. For the smaller circle, 2 squared pi is 4 pi. And so the area of a shaded region is 16 pi take away 4 pi, which gives you 12 pi. Here is question 3. Pause the video if you'd like to start answering it now. If you'd like a hint, then I will provide one now. So, what is the equation of a circle that has these 3 points on it? So, if I think about this logically, if a circle goes through these 3 points, it will also go through this point. So the circle will go something like this. It's not the greatest circle in the world. So it goes something like this, and okay, yeah, I'm sorry for this hideous diagram, but yeah, try to answer this question now using the little clue I gave you. Moving on to the solution, well, if the circle goes through these points, and I could extend it as well, right? And okay, extend it so it looks something like this. Well, we can see the midpoint of 2 and 4 is 3. Midpoint of 2 and 4 is 3. So the center of a circle, if you've drawn the diagram correctly, then you'd be able to identify the center of a circle as 3, 3. Now, we know the center of a circle. We can work out the radius as well. So let's draw a right angle triangle. So here is our radius, and I'll do a dotted line to show that this is a height of 1 and the base is 3. So 3 squared plus 1 squared equals radius squared. So 10 equals radius squared. So our center is 3, 3. Our radius squared is 10. And so the equation of the circle has to be this. Moving on, I'm going to revisit these integral maths resources. So I'm going to talk about this explore circle properties. As you'd know from learning about circle theorems at GCSE, the angle in a semicircle is always a right angle, so it's always 90 degrees. So no matter how you move this around, this angle will always be 90 degrees. Moving on to talk about the tangent, again, another important concept within circle theorems at GCSE is that if you have a line which touches the circle at one point, firstly, the line is called a tangent, and secondly, it is perpendicular to the radius of the circle. So again, no matter how much I move this around, whether it's got a negative gradient, as you can see here, or a positive gradient, or the gradient is 0, it will always be 90 degrees to the radius of the circle. This is one which some of you may not know about. So the perpendicular from the center of a circle to a chord bisects the chord. So if I move around and I'm making the chord larger, the perpendicular from the center, so the line from C to E, is always going to bisect the chord. So it doesn't matter if the chord is very small or if it is very large. It will always, so that line will always, the line from C to E will always be perpendicular to, it will always bisect the chord. So now moving on to the next skill pack. Here we have something which we've looked at already. Actually, sorry, this one is slightly different. So of course we can change the radius, but look what happens when we change the gradient. Now, you would have learned about this before as well. If the green line touches the circle, then we have one solution, one intersection between the circle and the green line. So in this case, it's a tangent. If it goes through the circle, then we have 2 points of intersection. So we can see, I'm not sure if I can write, okay, I can't write on the screen, but we can see 2 points of intersection, right, between the green line and the circle. And there's also another situation whereby we don't have any points of intersection between the circle and the green line. So here, look, we have 2 points of intersection. Here we have no points of intersection, but we could move it around so that the line is a tangent to the circle. Okay, I haven't done it, but there will be situations where the green line will be a tangent to the circle. Now let's look at a specific example. So we have the equation of a circle. At how many points does the line y equals negative 2x plus 2 cross the circle? So we need to substitute y equals negative 2x plus 2 into the equation. So replace the y with negative 2x plus 2. Then we will get a quadratic equation. So here it is. Now you could solve it to work out what the two x values are, or if there are any x values. But we just want to know if it crosses the circle or not. We're not actually concerned with what that values actually are. So to answer that question, we would need to use the discriminant. So as you guys know, b squared take away 4ac is the discriminant. I'm sure you learned about it with Miss earlier this year. And if it is greater than 0, we will have 2 roots. So 2 solutions for a quadratic equation. If it is equal to 0, we will have 1 root, and the line is a tangent to the circle, so it hits the circle at just 1 point. And if b squared take away 4ac is less than 0, then we have no real solutions to that quadratic equation. So let's see what the discriminant for this quadratic is. So the discriminant is 44. It's positive, and so it will cross. So yeah, as you can see here, there are two distinct real roots, so the line crosses the circle at 2 points. We have 2 points of intersection. You could try looking at a few different examples. Here we have one which, let's just see the answer. 28, okay, so it's positive again, but I'm sure there's going to be some which will give you different answers. So negative 76. Next, discriminant is negative. So if it's negative, there are no real roots, so the line does not intersect the circle. Have a go at answering some practice questions as well. So here you'd have to write 2, 1 or 0. Of course, you do your working out on paper. There's another skill pack which is of course focusing on the tangent to a circle. So here is a tangent to a circle. Let's go on examples. And so the task is to work out the equation of a tangent to the circle. So yeah, I'm sure you have done questions like this at GCSE, but it wouldn't harm to do some more practice. Sorry, here next. You could see a step-by-step method how to work out the equation of a tangent to a circle. So for activity 2, we will be doing a tangent to a circle exam question, and it's quite an interesting question because it's a 5 marker and I've broken it down so you focus on each mark individually. Again, this is the type of question which you may have seen at GCSE. So if you're finding it too easy, I'd like you to complete this extension question instead. As I said earlier, you might look at this question and be able to answer it just on the spot right now. And if that's the case, then that's great. And you could just do this question quickly and then do the extension question. If not, then just follow it step by step and watch me answer this question. So I'd like you to start off by completing the square on the x terms and the y terms, and hopefully you got x plus 2 squared take away 4 and y plus, negative take away y take away 5 squared take away 25. So this is cross out the incorrect versions. So this has a plus 4, this is a plus 4, let's cross these two out. And this has a plus, so let's cross this out. So this is the correct version of the solution because we completed the square. And it's clear that this first one is the correct solution. So that would give you 1 mark in an exam. Now, the next step is to collect the constant terms. So we have negative 4 take away 25 would give you negative 29. So all of a sudden we have negative 29 on the left hand side and we have 72 on the right hand side. So if you add 29 to both sides, and here I'll write add 29 to both sides, you will get 72 plus 29, which is 101. The center of a circle is, well, you guys should be able to work out the center of a circle from this equation. So it's negative 2, 5. So negative 2, 5. Why? Because the general term the general equation for a circle is this. AB equals the center. The gradient of a line joining the center to the point 84 is, so our center is negative 2, 5. So I write negative 2, 5 here. If we have two sets of coordinates, so this one and this one, how can we work out the gradient? So change in y, so I write 5 take away 4, change in y, over change in x. So negative 2 take away 8. So we have 1 over negative 10. So our gradient is 1 over negative 10. Y, because of change in y, over change in x. We're almost done. Therefore, the equation of a tangent is y equals negative 1 over 10 x plus c. Now let's substitute either these coordinates or these coordinates into the equation. I'll substitute 8, 4 just because there are no negative values. So 8, 4. So 8, 4 plus c minus 8, 10 plus c minus 4 over 5 plus c equals 4. So let's add 4 over 5 to both sides. 4 is the same as 20 over 5. And so c equals 24 over 5. So the equation of a circle, to give us our final mark, so the 5th mark would be awarded for the correct equation of the tangent, not a circle. Y equals negative 1 over 10 x plus 24 over 5. For the people who answered the extension question, I'm going to go through the solution right now. So it says prove that the lengths AB and BC are the same. So prove that these two are the same. Okay, so this is the center of a circle. We have a radius and another radius. And because AB and BC are tangents to the circle, we have a right angle here and a right angle here. Now, how do we prove that AB is the same as BC? So what I'm going to do is draw a dotted line in between these two tangents. So let's say this is O. So now we have two right angle triangles, right? The right angle triangles, let's say ABO, triangle ABO, and triangle CBO. Well, these are congruent. Why are they congruent? Because AO is the same as CO. Both are radius. They both have a right angle. So OAB equals OCB, right angle, and OB is the same as OB. They both have a shared side. So, using the ASA condition, we can prove that these two triangles are indeed congruent. Now, if they're congruent, that means this angle is the same as this angle. It means this side is the same as this side, and that this angle is the same as this angle. So ASA, and then we can write AB equals BC. So after you complete this video, I would like you to firstly have a go at those skill pack and explore activities. And after you've done that, answer at least 3 questions from the exercise level 2 questions. Mark your work using the answers on integral. And also complete the test titled C2. Some of you failed to do it last week, failed to complete test C1. So please make sure you complete test C1 and test C2. It would help you understand how good you are at answering these types of questions. So then you'll know what to work on over the half-term break. In terms of your half-term homework, firstly, make sure that both tests are complete. So tests C1 and C2, the 2 coordinate geometry tests, are both complete. Secondly, complete the exercise level 2 questions. So I expect you to do at least 3 questions in today's lesson, but during the half term I'd like you to complete the exercise level 2 questions. I did think about asking you guys to complete the coordinate geometry topic assessment during the half term, but instead I'd like you to complete the exercise level 3 questions, and I'm hopeful that if you complete the exercise level 3 questions as well as the exercise level 2 questions as well as these the multiple choice quizzes, then I'm sure that by the time I set you the topic assessment, you'll have done so much practice that you'll find that topic assessment easy, hopefully. So that's the rationale behind me wanting to delay the setting of the topic assessment and wanting you guys to do as much practice as possible on this topic. Please also make sure you are continuing to do your independent learning, continuing to recap and revise previous topics as well. Please make sure you speak to me if you require any help, if you have any questions, any concerns, and yeah, please make sure you do the work for today's lesson. And yeah, I hope you guys enjoy the rest of the week, and I hope you have a lovely half-term break. Take care and stay safe.